Hi, this is the bonus challenge, extra credit for energy systems. Um, I chose to just do my dorm room because I wasn't home. So my dorm room is relatively uncomfortable, pretty hot, especially up top on the bunk. But so I measured the thin hallway in the front first, and then idealized the other section to be a cube. So I added both of these volumes together for a total of 2,432.51 feet cubed. Um, so second, I use my psychrometer to measure the temperature and humidity of the environment. So it was 72.2 and we had 40% relative humidity. Then I went online and used the online psychometric chart to plug in the values, the temperature values. It requires Celsius, so I changed it to Celsius, and then we got our enthalpy values for each of the conditions. So from there, we know that the to determine the change in energy or the required energy, we need to use this equation where Q is that required energy. M of the air is the mass of the air at any given time, and delta H is the change in enthalpy. So we calculate the change in enthalpy with those values that we found from the psychrometric chart. Subtract that, we get 7 BTUs per pound of dry air. To find the mass of the air at any given time, we multiply the volume, which was that 2,432, and the density of air, which I looked up for the temperature, is 0.074 pounds per foot cubed. And I assumed that the ACH, or the air changes per hour, was pretty good in here, just because the ventilation's pretty nice. So I chose two, or assumed it was two, and we get a value of 360.1 pounds per hour. So then just plugging these two values into our equation here, we get that Q, or the amount of energy required, is 2,520.1 BTUs per hour. So, yeah, thanks.